Okay, second day on law of cosines, and I have set up a problem here where we know the sides, but we don't know the angles. Think about this. If I tried to use law of sines, I wouldn't know any of the angles. How could you get how could you get the answer when I don't have this or this? You have two variables. See what I'm saying? All right, so this is a better setup for law of cosines. Law of cosines is a squared plus b squared minus 2ab cosine of big C equals c squared. Brings up an important question. Which one's C? The one you're focused on. We're focused on this one, which makes this little c over here. And then a and b, they don't matter. We're going to go with majority. How many of you guys put the a on the top here? Not many. I was expecting more. How many of you guys put a down here? That proves that the urge to go from left to right overruled the urge to go from up to down. Interesting. Okay, so anyway, that's A, that's B. I get it. You guys could have reversed them, and it doesn't matter. The answer will be the same. Because when you square them and add them, do you think they care which one was on the left? And when you multiply them together, do you think they care which one was on the left? Doesn't matter. Okay, so I don't want to take the time to work this all the way through, but I would put in, because I just labeled it this way, 9 plus 8 and minus 2 times 9 times 8 cosine of, I don't know, equals 7. And when I solve that all the way down to do inverse cosine at the end, what'd you get? Did you check it with anybody? You had partners. All right, what did you get? What did you get? What did you get? You're all wrong. No, it's 48.2. Raise your hand if you had 48.2. Now, could it have been a no solution? It could have been a no solution, but not in this case. I'm just saying it's a good answer to have in your back pocket is no solution is possible, but you can have a triangle with sides 7, 8, and 9. Yes? Okay, hold on just a second. So you're saying, I heard you say 48.2, but I don't understand what you mean.
So when I did inverse cosine, I got 131.8.
Okay. My guess is that you did something wrong in your algebra as you got to near the answer. Because there's only one way to do inverse cosine. You were doing inverse cosine of the wrong number. All right. And if you just think about how big of an angle that would be, shouldn't this be close to an 8, 8, 8 triangle? So shouldn't the angles be kind of close to 60, 60, 60? You know what I mean? And this is about 50, so, this makes much more sense. I can just tell you that 130-something has to be a huge open angle. It just doesn't make sense. That last side would have to be way longer than the others, so something went wrong. All right. So this is dangerous unit because a lot of kids just trust their calculator, and if the answer comes out to 16, well, it's 16. But you should look at the question and go, does that seem reasonable? And 130-something, I think you knew something was wrong by how you said it. And so that's the key is, well, then I must have done something wrong in my math. All right. So let's move on to a different kind of question that law of cosines can solve. The more normal kind was like what we just did a second ago, where we have this is 8, and this is 8, and this one's 60 degrees. Do you get that that's a pretty easy one for law of cosines? Not enough people said yes, so I'm going to ask you to just figure this one out. Would you please figure out everything, which would be what are the other angles? What is the other missing side? I'll make it red here. Figure out the red side and the other two angles. Again, I didn't have enough people say that would be easy. Isn't it easy? Oh, it would be easy. Okay. Because if this is 60 and these two are the same, isn't it just a 60, 60, 60? Probably. Could it be anything else? What if this was actually like 45 and this was like 70s? That would add up to, I needed to add up to 120, so what would that, I can't do it in my head. 80, yep, that would work good. Why can't it be that? Okay, because then here's a reason that you could argue why it couldn't be that. Do you know this rule that the angle across from a side is proportional to that side? So what I'm trying to say is these two sides have to have angles across from them that are equal to each other. You get what I'm saying? Okay, so the angles have to be equal. And as soon as the angles have to be equal to each other, then they can't be those. And then they're going to have to add up to 120 to make a total of 180. So yeah, there's only one way to make this. All right. So I set that one up as a pretty easy one. What if this had been 50? This is a law of cosines question that is medium. It's not super easy. It's medium. You could figure this one out. Figure out how long the red side is now and what these two angles are. And just to keep our class all using the same letters so it's less confusing to grade, I can tell you this, angle 50, that has to be a certain letter, C. And then let's all agree then, of the two remaining ones, now I bet you everybody will just naturally pick what A would be. So go ahead and pick what A is, and I'll tell you which one you should have picked if you're normal. Now some of you are just going to, on purpose, not want to be normal, which is good. Anyway, I bet you picked A there. If you didn't, please change that to A and make this B, so we can all have the same. When I say normal, it's just because you're numbering from top to bottom or from left to right. And I know some of your counterculture people might want to just pick it different on purpose because I want to be different. All right, so find A and B and side C. I'll pause for a second while you give that a try. You should be really good by the end of today at law of sines, law of cosines, and finding the area. We'll do one more area. All right, I'm going to start. This is tough, and understand why it's tough. There's 16 parts to this. 16 parts you got to get right. If you don't put the right number in here, if you don't square it, if you don't add it right, if you don't put the right number in there, if you don't square it, if you don't subtract it right, you get what I'm saying? There's 16 things to do in order, and then you've got to do another bunch of steps to actually solve. And so there's a lot of steps. People often ask, why is pre-calc tough? And that's really the reason, because most people can do 2 or 3 things in a row right, but how about 16 and then a follow-up of another 8 steps, total of 24 steps to get all the answers right. And you can't make a mistake in any one of them, so that's why pre-calc is so hard. And you have to remember all this stuff from higher algebra too. All right, so I chose the letters kind of for you because of so we could all share, but A and B wouldn't have mattered. You could have chosen anything there. So I picked, well, A is 8 and B is 8, and it really isn't going to matter at all because they're both 8s. Minus 2 times 8 times 8, cosine of 50 is equal to little c, which I don't know. And then there'll be some small subset of this class that will have forgotten to take a square root. It's really easy to do because this is c squared at the end, so you're going to want to take square root of this. And that is just a long, nasty number that if I were you, I would actually type it all in at once. Do you know why? Because your calculator will do the order of operations right. Do you get what I'm saying? If you, by accident, just go in order, that, and then I subtract this, nope. Because then you just broke the law of order of operations, which is that this multiply here has to happen before the subtract. So I just type it all in, hit enter. Calculator knows the right order of operations. Then you square root that, and dice of destiny, row 1, last person, PW. What'd you guys get for C? Raise your hand if you had 6.7-ish, 6.8 maybe. Okay, good. Now, it does matter. You said 6.76. Do you get if somebody else used 6.8, they're going to get slightly different answers for the rest of it than you did? All right. So I'm curious, how many of you used 6.8? How many of you used 6.76? Okay, good. We'll just go with that. Now, do I really need that? Well, yeah, because now you're going to use the law of what? Law of sines. Okay. So now I'm going to do the setup for the law of sines. That's going to be sine of 50. Now, should I be strategic? You should always be strategic. Use strategery. So, I know, not a word, but it's a fun word. If you do this upside down or right side up, will it make a difference in how easy it is to solve? Yeah. If I do this, will it be the right way? Well, you really won't see it until the end. But I'm going to do sine of A over 8. And all I can tell is in retrospect, I used the easy way because the variable's on top. Bottom line, try to have the variable on top. Just saves you a whole extra step. Okay? If the variable wasn't on top, you would now have to reverse, flip this side and flip that side. It's actually putting both sides to the power of -1. Technically, it's math-wise what you're doing. Now that I got the variable on top, it should be pretty easy to finish this deal. And angle A, row 5, person, that's you, Kate. What did you guys get for the angle up here at angle A? Anybody else get 65? All right, a lot of heads nodding. So if that's 65, is it 65 even or 65 point something? I'm hearing just 65. Okay, fine. And then these three have to add up to 180. And, well, don't those two have to be the same as each other? Ah, that saves us a lot of time. So this is just 65 also. Why do they have to be the same? Because they're across from sides that are equal. All right, cool. Now I found everything. Yes? I get what you're saying, and in this case, that would have worked because I made these two the same. That made it a medium level problem, and you're right. She's saying, couldn't we have known that these two have to be the same, and it adds up to 180, and you could have just kind of used a little bit of logic there and figured out they were 65? Yeah. But that's only going to work this time because those two sides are the same. That's a good catch. All right, so what else do you have to know? Areas. So I'm going to give you 3 sides. I'm not going to use an equilateral. I'm going to do that same kind of thing I just did. 6, 7, and 8. Actually, I'm going to put the 8 down here because that looks a little longer. 6, 7, and 8. Would you agree they probably make a triangle? Okay. What's the area of that triangle? Okay, I agree. Somebody remembered the formula. 1/2, and I'm going to put A, R, E, A, because otherwise it'll look like side A. Area is 1/2 A, B, and then you guys know the rest? Sine C. Remember that the law of cosines is the only one with cosine in it. That's a hint. The rest of them have sine. I don't mean in the whole world of math, but of the common ones. Almost everything's in sine. Okay, so then there's a great formula, but what's the problem with it? You don't know what C is. So I get to teach you the last melon, the last thing. Well, couldn't you just figure out what C was? Sure you could. You could figure out what C was. By using the what? Law of cosines. But do you get that as 16 steps and probably by the end 24 steps before you finally have the answer? And then you got to go put it in this other formula. So there's a shortcut. This smart guy, I believe he was French. Last name is Heron, was probably pronounced like Haron, but we call it Hero. I don't know why. Hero is what you're going to typically have a math teacher call it. Hero's law, okay? And that is, instead of using this one, we can also use something else if we only have the sides. And it uses something called semi-perimeter. This is the last formula that you have to know. And by the way, remember, there's a long way to do it that you could do right now without Heroes. But Heroes does make it a lot easier. Okay, so here's heroes. It's that the area will be the square root of s times s minus, what do you think I'm going to do? Well, we don't even know what s is yet, so let me tell you what s is. All right, and I'll finish off the formula. S is the semi-perimeter. What is that? I bet you can piece it together. You know what perimeter means. Theorize with your partner on what the semi-perimeter of this triangle would be. Just take a guess, but you can be smart about that. Okay, according to Google, the reason it's called hero is in geometry, Heron's formula, sometimes called Hero's formula, named after a hero of Alexandria, gives the area of a triangle when the length of all three sides are known. And this one's pretty clear right here. It's s times s minus a, which is, what is a? It's one of the sides. S minus b and s minus c. But that depends on you knowing what in the world s is. And I said it was the semi-perimeter. Do you guys know what semi means? It's half of. Very good. Semi-perimeter, half the perimeter. Okay. So, what was the perimeter of this thing? It was 21. What's half of the perimeter? Half of 21, 10.5. So 10.5 was our semi-perimeter. All right. So s minus a, s minus b, and s minus c. So I'm going to go a is the square root of 10.5 times, I can probably do these in my head. What's 10.5 minus 8? 2.5. What's 10.5 minus 7? 3.5. And what is 10.5 minus 6? 4.5. The square root of all that, that's your answer. Now, that's a lot nicer on a test than doing a 24-step law of cosines followed up with a, or 1/2, area is 1/2 AB sine C. Okay, so that's like 30 steps, or you can do this. So you might not like this that much, but do you like 30 steps better? Okay. Some of you actually would because you don't have to memorize another formula. Well, this one really isn't that bad. Let's make the answer just a smidgen easier to figure out by making the sides add up to something nice. All right, let's make this 12, and let's make this 8, which would be 20, and let's make this 10, which would make it total up to 30. Figure out the area of that triangle using heroes from a hero of Alexandria. I tried to make the semi-perimeter nicer this time. The perimeter was 30, but then we're going to cut it in half, so it's 15 times 15 minus, I'm going to go from the biggest to the smallest. 15 minus 12 is 3. 15 minus 10 is 5. And 15 minus 8 is 7. And square root of all that, that's pretty quick. Beats 24 steps. Plus another formula. All right, Dice of Destiny. Now I'm not picking on anybody. Roll 4 for the row. And then it's fourth person. 1, 2, 3, fourth person. In the back, underneath the fish, what was the answer? And by verify 39.6. All right, awesome. And what was that? Number of fish in Alexandria? The area of this triangle. You're finding the area of it. Why don't you just do base times height? Well, you don't have the height. And it wouldn't be base times height anyway. It'd be base times height and then what? Divided by 2. All right. So you'd have to go figure out what the height is, which would not be a super easy task. I mean, it could be done, But this is a typical ACT question where there's the long way and then there's the easy way. And if you know this formula, this got the easy way, boom, you got the answer like in 5 seconds. Another kid's like doing the 24th step of the problem and finally gets it. But all right. Okay, so what's your homework for tonight? When you look at tonight's homework, it's gonna be called day 2. I would simply like you to do the first 3 questions in a row from where it says day 2. So I'm gonna pause for just a second. All right, so it's right here. It's the first, second, and third question. Those 3 questions are your homework. Have a great day. See ya.